I'm waiting for the start. Okay. So today what I propose is I'm going to, like now, I'm going to complete the lectures yesterday because at the end was quite rushing. Then in the afternoon at 2:30, okay, I'll let you guys ask questions if you have any. If you don't have questions, then I'll start lecture at 2:30, okay? So it's a hybrid of lectures and tutorial at 2:30. Okay. So yesterday, we were dealing with, I'm going to continue on the problem, okay? So yesterday, we were dealing with the beam, okay? So the beam, what we did is we had a Vx, okay? So we did a Vx, and the Vx value was 22750 from yesterday, okay? So 22750. So I don't think I did a very good job in terms of explaining what is going on, and I will slow down and do this again, okay? So we're going to find the shear in xz is equal to shear in zx, okay? So this is equal to Vx over Iyy, okay? Then we have Qy divided by T, right? So we already know what is the thickness, right? So this is the thickness, and the thickness value was, we had the thickness value. Hold on. So the thickness value was 11.8. Was it 11.8? Hold on. Let me check from yesterday. I did not write the thickness value down, but I'm going to find out. So the thickness value, okay, so the thickness of the web is 7.24. Okay, so the thickness of the web is 7.24. 7.24. So the thickness we know is equal to 7.24 times 10 to the power minus 3. Okay, we also can get the value of Iyy. Okay, so the value of Iyy is, we have to use yy value is because the Vx, okay, the Vx is intersecting the axis in yy, right? So that's why you have Iyy down here. So Iyy will be equal to 9.03 times 10 to the power minus 6. Okay, so 9.03. This is meter to the power 4. This is meter. So Vx we also know, right? Vx we are made aware that is equal to 22750 Newton. So
Professor, I thought Vx was 16,000.
Say it again.
I thought Vx was 16,000 yesterday. We wrote down Vx as 16.
Was it 16? Wait, I'm looking at Vx. Oh, yeah. Wait. Yeah.
That was 22,752.
I'm looking at my. You're right. Okay, I got it wrong. I was looking at the other. So it's 16,000. Thank you. Okay, a pint for you again, or orange juice. Okay, so now, as usual, the issue is going to be Qy. Okay, so Qy. So Qy means first moment of area about y-axis, right? So the term Qy is first moment of area about the y-axis. Okay, so we also are aware that yy is the centroid. Okay, yy is the centroid. So from here, right? So Qy is equal to a x bar. Okay, so I'm going to construct the shear flow first. Okay, so we construct the shear flow. So as usual, we apply the rule that the web, right? The web controls the flow. Okay, so it wants to move from right to left. So where element B is, okay, so over here is our element B. Okay, that is our element B. So we are also aware that the shear, the flow will be going in this way and on top. Okay. So now we want to find QY, Q first moment of area, but the y-axis is going to AX bar. Okay. So I'm going to blow up this view. Okay, I'm going to blow up this view. Okay, so I'm going to draw that view. Okay, so I'm going to blow it up. So you might say, Eugene, what are we looking at now? Okay, so the transformation is still the same. All right, so this is X, this is Y. Now over here, okay, over here is our element B, right? Now, let me be very clear over here. If I pick another point here, I pick one point here, okay? So this one, I put a element C, right? So if it was element C, we have this area, okay? So this is the area to consider. Okay, so some of you might ask, why didn't we use why this was not considered? Not considered. And this is because the reason is the first moment of area, or the Q, cannot cross the centroid. Right? This is for element C, okay? Right? So cannot cross. And then the X bar, okay? So that's why we don't consider the one I shade in red and color with blue, okay? That's why we don't consider this arrow, this side, okay? So we don't consider this one. So the X bar, okay? The X bar is basically, if I were to draw X bar, okay? This distance is your X bar, okay? Now, coming back to element B now. For element B, can anyone tell me, if we look at element B, what is the area? Anyone? For element B?
0.
Exactly. So for element B, okay, for element B, right, the area is equal to 0. So therefore, right, the first moment of area Y, okay, at element B is equal to 0, right? So when that's the case, okay, so when that's the case, the shear XY, sorry, the shear XZ, you put XY, no, XZ is correct, about point B is equal to 0, okay? So I want two things I want you all to be clear about this. This is proven mathematically or by applying what we have learned, okay? So by applying what we have learned, we found that QY, okay, at element B is equal to 0. Now, the other reason is this, okay? So last week we do our tutorial. We also formulate a new rule, okay, which I did not know until I was doing the example with you guys, or a student asked me what if the point is there, and I did not know the answer until I start analyzing. Another one is above the centroid, okay, so above the centroid YY, right? If I were to like zoom in, okay, you will have shear flow moving both ways, right? And based on the analysis that we have created, the Q only can be in what? One direction. Okay, so by using that logic is also true. Using mathematically to prove the concept is also true. Okay, so that is why the shear XZ at point B due to Vx is equal to 0. Okay, now do you understand? Is it better now? Yes or no? If you have any question, ask now. Okay.
I have a question.
Yes. Good morning, Miriam.
Good morning. So when we were talking about the reverse flow thing, you said in the horizontal pieces it's not considered reverse.
Now,
So
this is because is
so
this part alone is above the centroid. So we have a line to divide, yes or no, right?
yeah.
As long that section, the section that you consider either above or below the centroid cannot have a reverse flow.
Oh, okay.
Okay,
Yeah.
okay. I know you are clarifying because sometimes it can be, sometimes it cannot, right?
Yeah.
Okay. Now, then the next thing to consider is the other flow path now. Okay, so the next one, same diagram. Now we are going to consider, right? Now we are going to consider this. Okay, now we are going to consider Vy. Okay, now we're going to consider Vy is equal to, now what is our Vy value? Let me look. I don't want to be losing pints again. 25,000. Right? Okay, 25,000 Newton. So now we are again going to construct our shear flow. Okay, so our shear flow will look like this. So this is where we finished off yesterday. So now we also know that element B, right? Element B is over there. Okay. So for this case, we are going to find again the shear xz is equal to shear zx, and this will be equal to, so your Vy, so Vy over Ixx, Qx, and T. Okay, so we know I don't know the thickness. So I think the thickness will be the same as what was before. So the thickness will be 7.24 times 10 to the power minus 3 meter. Okay, then your Ixx is equal to, so we go back here, is 40.8 times 10 to the power minus 6. Okay, so we have 40.8 times 10 to the power minus 6 meter to the power 4, right? And then Qx we don't know, but we know that Vy is equal to 25,000. So from here, we have to find Qx. Okay, so Qx will be equal to the Q, or before we do element B, right? Element B is a wide flange configuration. Okay, we have a wide flange configuration. So when wide flange configuration, for this case, Q is equal to 1. Okay, Q is not equal to 2 because if Q is equal to 2, it's usually for box beam, right? So over here, we know that the Q, the summation of Q will be the Q of the flange plus by Q of the web up to centroid. Right, so the area to consider, okay, the area to consider is here, and here. Okay, so there's an area to consider. Okay, so the width, I should be more organized today. Okay, I'm trying to get my notes that I can see the values. So for flange, the width, so the width will be BF. So BF I give up. I can't see. I'm